All right, good morning, good evening, good afternoon, and welcome once again. Today, we're going to talk about relations. This is lesson 1.6, and of course, I am Mr. Stiger. So what I want to make sure you guys do is have your books open to page 43. Make sure you have your notebooks out, and if you also have the bell work, paperwork, please pull that out as well to go over that. Okay, so today's lesson, we kind of talked about different relations in terms of sequences of numbers. Okay, so we're going to have a lot of tables in relation to this and making sure you guys can understand. So before we begin, we have a couple of bell work things. So what we did in class today is I moved through these slides pretty quick at a 1-minute interval. So what I want you guys to do is please look at this graph. Okay, remember on the bell work, what I want you to do is put it on the next block that you have. This is lesson 1.6. Please put lesson 1.6. For number 1, please make sure you write down which inequality it is. Okay, take a guess first. All right, and then so let's talk about it. We haven't really talked about this, but a dotted line in this sequence represents that it is not an equal to. Okay, so what that means is that it cannot be these, because this line, it would be a solid line if it's equal to. And so the best way to solve this would actually be to put 0 in for x. Okay, and so if you put a 0 in here, what I mean is on a coordinate point. Remember, the coordinate points are x, y. Right? I'm only going to show you this example on the first one, x, y. So remember, on a coordinate plane, x point would be right here, and it's going horizontally. The next point, y, would be vertically. So if I put a 0 in here, the intersection is going to be -1, which is the case. So the question is which side of this line are all the answers in? So is everything as a y coordinate going to be greater than -1, or is it going to be less than -1? So if I had a 0 here, and say if I went in here and I put a 1 into this equation, okay? So if I put a 0, your line is right here. If I put a, basically what you want to do is find out which way it goes. Every coordinate of a y value, is it greater than this line here, or is it less than? Well, it's greater than, so the answer to this is actually A, okay? Hopefully you guys understand. So every coordinate, so if I put a 0 in here, 0, is 0 greater than -1? The answer is yes, it is. So a point would be here, so that's why you did it. If I put a 0 in here, so it'd be 0 is 0 less than -1? Is -1 greater than 0? The answer is no. So that's how this makes it not complete. So this is a false statement. This is false, okay? This is true, all right? So that's how you know it's A. All right, work on this one, see if you guys can get this one. All right. Looking at this line, this is equals 2 lines, so these two are gone, so now you're left with these two. A good note of reference here would be to find a point. What point is this? 0, 0. Ladies and gentlemen, I always love to use the origin of 0, 0. It makes things so much cleaner and easier to solve, okay? So this, we won't actually be covering this type of material until later in the year, but it's kind of good for you guys to see it now, just so you get it. So what's 0 plus 0? It's 0, of course. So the question is this a true or false statement? Is 0 greater than or equal to 3? The answer is what? This is false. All right? That has to be the answer. Okay? Which graph shows the inequality of this? Take a guess. Look at it for a second. All right, so same with the inequalities here. So let's work on the origin. Okay? Same thing. All right, if I put in here for an origin point, so what I mean by that is if I pick 0, 0 point. So if I put 0 for y is less than or equal to 0.5 times 0 plus 1. So that's going to be 0 is greater than or equal to 1. Is that a true statement? Yes, it is. So 0, 0 has to be a point. Is it a point right here? The answer is no, it is not. So it is not B, and it is also not D. Okay? So we're left with A or C, because you can see the 0, 0 is in there. Now what you can do, ladies and gentlemen, is do one of two options. Okay? You can pick a random point that is not shared by both. So if I look here, I see 0, 1, 2, 3, 4. So the point would be 0 over, well, I could have done that. It would be 4 over, 0 up. Okay? Let me just pick this point right here. All right? So it would be right here. So depending on what happens when we plug this in, will determine whether or not it's a true statement. Okay? So if you plug 4 And to here, what is 4 times 0.5? It's actually 2. So 2 plus 3 is y, and then y is 0, right? So 0 is greater than or equal to 3. So is this a true statement? The answer is yes, it needs to be a point. So which one of these is true? It's actually A, okay? If you don't understand that, that's okay. We'll cover this later on in the year. I just want to make sure you guys have this bell work. All right, mathematical practices. Make sense of problems and persevere in solving them. All right, here's the real numbers. We're covering quite a few standards today. We're jumping all over the place, okay? All right, you defined appropriate quantities in descriptive modeling. That's what we've been covering. Now we're going to talk about relations and interpret graphs of relations. It's important that you guys, at this point in your academic career, can look at a graph and interpret what it is. By looking at it, you should be able to say, oh, I know what's going on here. And if you don't, that's what we're covering today. All right, so on page 42 is a whole bunch of beautiful vocabulary. Ladies and gentlemen, please read it over right now before we move on. All right, hopefully you read that on page 42. The reason is it will help you in the process, okay? All right, express these following points as a table, a graph, and as a mapping. So what I've done is I actually imported in here a nice little graph. So what I want to make sure you guys do is understand the concept of putting in these points. So the first point, 4 over, 3 up, that's 1 point, okay? -2, -1, 2, so it would be 2 over, -4 down, and the other point would be 0, -4. All right, there are your points, okay? Now, that is a table, or I'm sorry, that is a coordinate plane system. That's the graph. This is set up as ordered pairs. The table is going to be set up like this, okay? X, Y. Change the color. All right, your X, Y tables. 4 points, 4 lines. So it's simple. The tables 4, 3, -2, -1, 2, -4, 0, -4. Okay, I want to make sure you guys understand what the tables are. Now, mapping. Okay, what a mapping is. A mapping is set up where, this is mapping. All right, you have the domain and your range. Now, these two terms, okay, were discussed on page 42. All right, there's another example in your book on the top of page 43. Okay, so what you do is on a mapping you have a nice little square set up here. Whoops, my head got in the way. All right, and then you have a little square set up here. And then what you do is you find the common numbers. So what I mean by that is easy when you have a table set up like this, okay? So what you're doing is you're actually putting in the numbers, and it doesn't matter what sequence you put them into, okay? So for example, I'm going to leave it set up like this. So the domain is all x values that you have. So it'd be 4, -2, 2, and 0, all right? They're all 4 unique. Now your range is going to be the same numbers, 3, -1, whoops, sorry, got a little itchy on that one, -1, and then you have a -4. But since you have 2 of them, you only got to put it down once, okay? Now on mapping, what you're doing is you're making sure that now you're just connecting the dots, okay? So when you connect the dots, 4 goes to 3. So these two go together like this, all right? -2 goes to -1, and now here's where one of your points is 2, -4, and the other one is 0, -4. So you pretty much draw a mapping just like that. Okay, that's what a mapping is. And what this is what this is doing, and this is going to go lead into the next lesson, which is talking about functions. Okay, so this is your kind of your setup and your precursor to everything. Okay, so this is set up right here as coordinate points. Okay, this is your graph, your table, and your mapping. Please make sure you guys have those down in your notes. All right. Now, ladies and gentlemen, what I want to make sure you do is determine the domain and range for a relation. Okay? Domain and range, you can kind of use whatever you want. If you guys look on page 43, okay, it gives you a different example. But on my example, what is the domain? Remember I said the domain equals, okay, x values. All right? It's important for you guys to remember that. And the range equals y values. Okay? It is very important that you guys remember what the domain x values are and the range y values are. The reason is that we are going to cover this with quadratics. When we go into graphing, we go into linear equations, I'm going to ask you what the domain and range is. If you don't know what those terms are and you get confused with it now, you're going to be really confused later. Okay? So what you guys need to remember, the first number in the sequence is always going to be the domain, which is the x values. Okay? The range is always the second number, which is the y values. Okay? It's very important that you guys have these down and memorized. So, what is the domain? The domain is going to be 4, -2, 2, and 0. Okay? Now, what is the range? The range is going to be 3, -1, okay? And then it's going to be -4. All right? That is your range. Please understand that. Okay? Those are your numbers. That's the values that you have. All right? If you guys have any questions on that, please let me know. But what's cool about this, okay, is that this is the same setup as you remember when we did right here. Okay? When we did this sequence here, that's why we do the mapping. When you do mapping, it kind of puts it in an illustration of what you'd want to do here. Okay? If you guys have questions about that, let me know in class. All right, now it's your turn. Okay? I want you to create a table, a graph, and mapping for these points. And then determine the domain and the range. Okay? Try to do this on your own, ladies and gentlemen. And then when I come back, we'll go from there. All right, express it as a table, a graph. Okay, I'm just going to make the mapping of it. All right, the mapping, because the mapping is kind of the harder one, I think, for some of you guys to do. All right, and it gives us the domain and the range. Okay. All right, so when we do the mapping sequence, all right, what we have, make sure I have those, is, let me change this. Let me cheat the system here. Give myself a little box. Whoop. Instead of me drawing it out, just do that. All right, so now we have our setup. Okay, so we have our x values and our y values. Now, ladies and gentlemen, let's just do this meta. So we got a 4, all right, 3, -4, and 0. Then we have a -3, a 2, a 1, and a -3. Oh, and we already have a -3, so we don't do anything else with it. Okay, so we don't write down the -3 twice. All right, now we change it up here. Now we draw it together, right? So it was 4, -3. It was 3, 2, -4, 1. And then, ladies and gentlemen, it was also, now, here's the trick. Okay, it's up to you on how you want to draw this particular piece of lovely awesomeness. Okay, the mapping should draw like that. Okay, I have the fortunate of doing a different color. Okay, but if you want to draw it kind of to the outside, you can, but this is how it's technically supposed to look. Okay, I have the fortunate ability to pick a different color. If you have 2 colored pens or a pencil, if you're doing this in pencil, you have the opportunity to draw in a different color, maybe you should kind of stand out. Okay, so that way when you're looking at this mapping, if I were to say to you, what are the 4 points on a graph? You could tell me the 4 points. 4, -3, 3, 2, -4, 1, 0, -3. Okay? That's how you want to be able to read that. So it's very important that you guys can do that. All right, independent, dependent variables. On this exercise here, ladies and gentlemen, it talks about warm climates, average. Okay? What it is basically, let's just identify the independent and dependent variables for this function. All right, average amount of electricity used rises as the daily average of the temperature increases and falls as the daily average temperature decreases. So what is the independent and what is the dependent variable? Okay, so when we're doing with this particular example, all right, if you guys turn to page 44 in your book, you'll see actually talking about dance and movies. Okay, in this one, what we're talking about is one of these variables is dependent upon the other. Okay. The independent variable in this case, all right, the independent variable in this case is what? What do you think it is? It's the temperature, okay? The temperature. Excuse me. And then what happens is, ladies and gentlemen, what is the dependent variable? Dependent variable is the other one, which is, where is that? The warm climate's average amount of electricity. Sorry, I was looking for the word electricity. All right, the reason that's saying is you can't control what? The weather. But as the weather goes up and down, guess what happens? When the weather changes, the electric current changes. I see it every year on my electric bill. In the wintertime, I'm spending like 70, 80 bucks. In the summer, I see my electric bill shoot up to about $250. Why? Because I don't use really any electricity in the wintertime, but in the summer, I kick it up because of the AC. So, electricity is dependent upon your temperature. All right? Same with this. Number of calories you burn increases as the number of minutes you walk. All right? Identify the independent and dependent variables. Okay? So, what you're doing is your independent variable in this case is going to be what? Your minutes. Okay? The more you walk, the more what? Calories you burn. Okay? Hopefully you guys understand that. So dependent would go to calories. Okay? So if you sit on your butt all day, like when I did when I was accounting and finance, guess what you don't do? You don't burn much calories. So if you eat really bad, which I did, guess what you do? You gain a bunch of weight. It happens. Okay? Now, know that. All right? So identify the independent and dependent variables for each relation. You guys go. All right, air pressure inside a tire increases with the temperature. So what is independent? It is temperature. What is dependent? The air pressure. Okay? Air pressure is dependent. Okay? As the amount of rain decreases, so does the water level of a river, also known as a drought. So, what is the independent variable? It is rain. Okay? Rain is independent. The more it rains, what happens? This is dependent water level. Okay? Make sure you guys understand that process. All right. Now it talks about analyzing graphs. This is the last part of the lesson. If you guys turn to page, which you don't have to turn to, 45. Well, it's actually on the bottom of 44. Sorry. 44, it's simple graph. Graph represents the temperature inside of a winter day. Describe what happens in the graph. So look at this. The temperature inside on a winter day. What do you think is happening here? Okay? When you're looking at this, in class, I'm going to ask, what happens here? What do these peaks and valleys represent in the wintertime? Okay? What it's representing when I see it is you're cold. You turn the heat on, and it gets up to, in your thermostat, you have it set to like 78. That's hot. It's 78 in your house. Okay? Maybe in our house, I think our temperature in the wintertime is about 70 to 68 degrees. We like to keep it about 68, nice and cold. And then what happens is your temperature goes up to 68, your heat kicks off. All right? Your heat turns off, your house gets down to about 66, 65, that's too cold. Heat kicks on. Heat kicks off, heat kicks on, off, on, and then eventually you just turn it off and let it ride. That's what that means. Okay? So what I want you guys to do now is describe what is happening in each graph. Okay? On the printout notes I'll give you these graphs, and I want you to actually physically write it out, what you think happens. All right, what do you think happens here? All right, the more time you have is what? The farther you go. All right, so initially what's happening, if I'm looking at here, is that you're traveling a good distance in a short amount of time. And then what happens? Okay, your distance does not go as much as your time. You know what this is telling me, ladies and gentlemen, is you are cruising along here. So this is like a daily commuter from anybody that lives out here in the East Valley. Okay, at 6 o'clock in the morning, you're driving on the 202 freeway right here. And you're cruising along. You're making fantastic time. And then, ladies and gentlemen, you hit the Loop 101 ramp. Okay, when you hit the 101, then what happens is you hit what's beautifully called rush hour traffic. And when you hit rush hour traffic, ladies and gentlemen, guess what you do? Your time creeps along and you don't move. I did the drive from where I live here to Phoenix for over 10 years, and it was 32 miles one way. Ladies and gentlemen, if I left beyond 6 o'clock, it would take me an hour to get there. Okay, I'd be cruising along just like this, and then all of a sudden, my distance would stop, and but the more I went, it was just crazy. All right, income and time, change in income. What does this mean? This means, ladies and gentlemen, when you first start to work in your life, are you going to make a lot of money? No. But as time moves on, guess what? You make more money. Okay. What's interesting to me is this little dip right here where it kind of levels off. Maybe what you're having is you're working, and then you stay at a stationary job, and then you know what? You go working again, you start working, or maybe this is when you take break time when you don't actually make much money. Okay. Like you're making the money throughout the day. All right. Maybe you're a waitress. You're at the beginning of the day, you start making a little bit of money, this is great, and then the lunch crowd comes in, you're like, sweet, lunch crowd, and then you get a break, and then you come back, and guess what kicks in? The dinner crowd kicks in, so your income starts to go up. Something like that. It's up to you on that opinion. Okay. That's it for this lesson, ladies and gentlemen. I hope you enjoyed it. What we're doing is making sure you guys can look at pictures, graphs, and interpret the data that's presented to you. Okay. Until next time, ladies and gentlemen, make sure you do your homework, and I'll see you in class.